Hello, in this section I will derive using logarithmic differentiation. So what is logarithmic differentiation? It's just another technique to differentiate more complex equations. When would I use logarithmic differentiation, do you ask? Anything with radicals, exponents, natural log in the equation. So for example, let me write, example would be like y equals radical 5 x plus 1. So there is a radical, so that's a big clue that you would use logarithmic differentiation. So what are the steps for logarithmic differentiations? So what you're going to do is take the log. Step 1, take the log of both sides. Step 2, take the log, or actually the natural log both sides. Apply the properties of logarithms. Differentiate the equation in respect to x. Solve for dy dx, and then once you have dy over dx by itself, you're going to get a y, and then just replace y with the original equation. So and then you also need these rules. So the derivative of ln, anything with a natural log, it's going to be kind of like the chain rule, 1 over u times u prime. And then these are some reviews when expanding natural log, because we will have to use that when we expand. So when you're multiplying, you're really adding. When you're dividing, you're really subtracting. When you're raising, and then when you put the power in front of a natural log, and ln e are inverses, it becomes whatever your power is, and then that natural log will 1 and 0. So find the derivative. So let's do an example 1. So find the derivative for the following equations. So what we're going to do is step 1, take the ln of both sides. Okay, so that's what I'm going to do. I'm going to take the ln of both sides. So on the left side, it would be ln of y equals ln of this whole thing. You could rewrite this as x squared, but in this one, I won't, instead of using the cube root, I convert it to power. So that would be like times 7x minus 14 raised to the 1/3 all over 1 plus x squared raised to the 4th. Okay. Now what I'm going to do is I'm going to use my properties to expand the right side before I take the derivative in respect to x. Okay, so on the right side, just use your property of logs. So this would be 2 natural log of x and then this is multiplication, so it's going to be plus, and then you have a power. So when you have a power, when expanding, put the power in front of the natural log. So it's going to be 1/3 of ln of 7x minus 14. And then we are dividing. So when you're dividing, you're really subtracting. So it's going to be minus, and then there's a power in front of that. So that's going to be 4 natural log of 1 plus x squared. Okay. Then what I would do is take the derivative in respect to x. So over here, the derivative ln y is going to be 1 over y times it by the derivative of y, which is 1, times it by in respect to x. So this would be dy dx. Okay, this one over here, the derivative, well, 2 is a constant, so you could just ignore it for right now. So it'd be 2. And then the derivative of ln of x is going to be 1 over x times the derivative of x, which is 1, and then dx over dx. But I don't think you need to put the dx over dx because we know that dx over dx is 1. So you could just know that for right now. So, and then over here, the derivative of this whole thing, 1/3 is a constant. So it's going to be 1 over 7x minus 14. And then take the derivative inside the parentheses, triangle rate. So the derivative of 7x minus 14 is just 7 minus 4. And then the derivative of this, it's going to be 1 over 1 plus x squared times it by the derivative of 1. The derivative of 1 plus x squared is going to be 2x. So when you clean this up, the right side should look something like this. 2 over x plus, so this is a constant, so 1/3 times 7, that's 7 over 3 over 7x minus 14. And then over here, this is minus, and then 4 times 2x is 8x over 1 plus x squared. Okay, then I think what we'll do is simplify this part. So it's like saying you can write this as it's a complex fraction, so 7 over 3 divided by 7x minus 14. I'll just do the bracket method. So we have a 1 and a 3, so my common denominator would be 3. So that would be 7. And then it's going to be 3 times 7x minus 14. So when you do that, clean that up, that would be 21x. Sometimes 3 is 21x, and then 3 times negative 14 is negative what is that going to be? Negative 14 times 3 is 12, negative 42. But since you're dividing each term by 7, this would be simplified as it would be simplified as 1 over 3x minus 6. Okay. And then just bring down the rest. So 2 plus x is just 2 plus x. And then it's minus 8x over 1 plus x squared. And then we have 1 over y dy over dx. So what you want to do is solve for dy dx. So to do that, you're going to multiply both sides by y. So here and here. So when you solve for it, you're going to get dy over dx equals to y. Okay, you have the options of adding, combining this side by collecting like terms, or you could just leave it like that. That's perfectly fine. And then the last step is replace y with the original problem. So the original problem is this thing. Okay, so your final answer is going to be dy over dx equals to x squared So this is your final answer. Let's do example 2. So just like the last one, find the derivative using logarithmic differentiation. So the first thing I would do is rewrite. I think it would be easier if I rewrite the problem as x and then times 1 plus x squared raised to the 1/3, right? Because this is the same thing as the cube root. Okay, then you're going to take the ln of both sides. And then you're going to use your property of log before you take the derivative in respect to x, right? So this would be ln of x plus, because we're multiplying, and then you have a power of 1/3, so you put the power in front of the natural log, so it's 1/3 ln of 1 plus x squared. Then what? This would be ln of y. Now you may take the derivative in respect to x. So over here, the derivative of ln of y in respect to x, well, that's 1 over y times by the derivative of y, which is 1. And then you have to add a dy dx. Over here, the derivative of ln of x is 1 over x times it by the derivative of x, which is 1. And then respect to x would be dx over dx, but you could just ignore the dx because it's 1. So in reality, it's just 1 over x. The derivative of this, 1/3 ln of 1 plus x squared. 1/3 is a constant. And then the derivative of this is going to be 1 plus x squared times it by the derivative of x, the derivative inside of this. So the derivative of 1 is 0. The derivative of x squared is 2x. So you clean this up. This would be 2x over 3 times 1 plus x squared. And this would be 1 over x equals to 1 over y dy dx. Then what you do is try to get dy dx by itself by getting rid of this y. And to do that, you're going to multiply both sides by y. Okay, so on the left side, it's just going to be dy over dx equals to y times this whole thing. Okay, so you do have the option of simplifying this part, right? If you're adding a fraction, you need a common denominator, or you could just leave it like that. That's perfectly fine. And then last step is replace y with the original equation. So your final answer is going to be dy over dx equals to x, the cube root of 1 plus x squared times 1 over x plus 2x over 3 times 1 plus x squared. Okay, so that is your final answer. Let's do example 3. So take the natural log of both sides. So this would be natural log of y equals, and then take the natural log of this. So natural log of x to the 2 over x. Then on the right side, use your property of natural log to expand. So you have a power, so put that in front of natural log. So it would be 2 over x ln of x, right? Because this goes in the front and then you're left with x. Okay, and then what we're going to do is, I guess you could take, or what you could actually rewrite 2 over x as 2 to the 2x to the negative 1 times ln of x. Then what you could do is take the derivative in respect to x. So this is going to be 1 over y dy over dx. And then over here, when you take the derivative in respect to x, you got to apply what's called the product rule. So if you recall, product rule is f prime of g plus g prime of f, right? So this whole thing is my f, and then this whole thing is my g. So f is 2x to the negative 1. F prime would be negative 2x to the negative 2. And then g is going to be ln of x. G prime is going to be 1 over x. Okay, so just apply the product rule. So f prime is negative 2x to the negative 2 times it by g, which is ln of x, plus g prime, which is 1 over x, times it by this 2x to the negative 1. And then this is going to be, when you simplify this using positive exponents, this would be minus 2 over x squared times it by ln of x plus 1 over x times, and then 2 to the x to the negative 1 is to be expressed as 2 over x. So when we clean this up, this would be negative 2 ln of x plus 2, because 1 times 2 is 2, all over x squared. So you have 1 over y dy over dx. And then what you can do is get y by itself, get dy over dx by itself by multiplying both sides by y. So you get dy over dx equals to y bracket negative 2 ln of x plus 2 over x squared. Okay, and then I guess the last step is replace y with the original function. So your final answer should be dy over dx equals to x to the 2 over x. So x to the 2 over x bracket. So that's negative 2 ln of x plus 2 over x. Okay, so that is your final answer for that one. And then I think there's one more. Okay. So first step is take the ln both sides. So this would be ln of y equals to ln of x plus 2 squared. And then on the bottom, instead of writing a square root of x squared plus 2, just write it out as x squared plus 1 to the 1/2. That would be a lot easier. And then just use your property of logs. So on the right side, this would be 2 ln of x plus 2. And then you have a divide sign, so you're going to put a minus. And then you have a 1/2, so that's going to be 1/2 ln of x squared plus 1. And then over here you have ln of y. Okay. Then what you're going to do is take the derivative in respect to x. So this is 1 over y dy over dx. And then this is going to be 2. And then the derivative of this is 1 over x plus 2 times it by the derivative of x plus 2, which is just 1. minus 1/2. So this is 1 over x squared plus 1. And then take the derivative inside, so that would be 2x. Okay. So that would be, what would this be? This would be 2 over x plus 2. The 2's cancel, so you're left with negative x over x squared plus 1. And over here, this is 1 over y dy over dx. Now, this time I'm actually gonna simplify this part. I'm gonna subtract. I'm gonna find my common denominator and combine like terms because I feel like something will cancel. So what would be my common denominator? It would be x plus 2 and then x squared plus 1. Okay. So over here, this is missing an x plus 2. So multiply by x plus 2. And then over here, we're missing it in x squared plus 1. Okay, and then so this would be you clean this up. This is going to be 2x squared plus 2 minus x squared plus 2x over the common denominator, which is x plus 2, x squared plus 1. And then this is going to be 2x squared plus 2. Boil this out. This is negative x squared minus 2x. And then simplify the numerators. So we have 2x squared minus 1x squared. That's x squared. Then you have minus 2x plus 2. X plus 2. X squared plus 1. You can't factor x squared minus 2x plus 2. It's possible, so we'll just have to leave it like that. Then just solve for y. Multiply both sides by y. So you get dy over dx equals to y bracket minus 2x plus 2. And this is going to be x plus 2 x squared plus 1. And then what you're going to do is just replace y with the original problem. So if I do that, I will get x plus 2. Now, what can you see if that cancels? The x plus 2. And so you get dy over dx equals to x squared minus 2x plus 2 over, you're left with this and this. So square root of x squared plus 1 times by x squared plus 2. I mean, x squared plus 1. And then you could do one last step. Notice that they're both x squared plus 1. So we get square root of that would be this. You can rewrite this as parentheses x squared plus 1 to the 1/2 times it by x squared plus 1. And we know that when you're multiplying with the same base, you add the power. So your final answer is going to be dy over dx x plus 2 times x squared minus 2x plus 2 all over x squared plus 1 base of 3/2. Final answer. Okay, I guess that's it. Yeah, that wraps up for today. Thank you. Bye-bye.